Recording here. Okie doke. Well, thank you all for joining. Today, we are going to talk about energizing GIS technology for the future. Our presenter today is Mr. Kenneth Bryant. He's a senior account executive for utilities and enterprise. He has over 30 years of experience in senior technical and project management roles, and as well, he is a United States Air Force veteran. Kenneth's extensive experience includes full life cycle of development for photogrammetry, digital mapping, GIS, Oracle, SAP, utility services in Europe as well as North America. He has worked on delivering innovative highway technologies and supported reliable and quality services, as well as leading new business development efforts in the infrastructure, smart cities, digital twins, utilities, and telecommunications sectors. So we're very excited to have Kenneth with us today. And with that, Kenneth, I will turn the floor over to you.
Thank you, Matt. Hope everybody's doing well up to date. I'll just come in and I'll just give you a little preview of what we're going to talk about today. One thing I'm going to start out with, I'm trying to take you through the journey that we go through in terms when you're doing a project and you're trying to be innovative with data. Talk about the importance and reliability of data, how automation is driving safety and efficiency. I picked out these two particular projects that we are associated with in the UK. I feel that these two projects demonstrate the benefits of how data sharing can unlock the benefit and value of your data while you build a critical infrastructure. So if you have any questions, feel free to put those in the chat. You can ask them at the back end, or you can email me later after the presentation. Okay, so if you think about data, the journey that we took on those two projects doing the National Underground Register was that we looked at the quality of the data. In terms of data, bad data, it's costing utility companies and industries quite a bit of money. It's reported at $3.3 trillion a year. Wasting time trying to validate and correct information. Sometimes people throw a large group of people at the data trying to get the errors out, but they still have problems in there. So lost revenues, you get fines from regulators for having your equipment out in the field too long, or either there's outages that's happening because you can't rely on the information that you have. So with bad data, you can't make good decisions with that. With bad data, you put lives at risk. People like ourselves who are at the forefront of managing assets, whether that be utility data, whether that be emergency services or road networks or building houses and things like that, we rely on the information that we have to make sure we're able to provide that service. So just a couple tidbits that I've gained over my 30 years of experience of data capturing, doing project management. You need to know where your data is. What's the current state of your data? You wouldn't believe that in the UK, especially in London, there's a large utility company that's there still using paper records with their data, and still have data that's disseminated in various different silos. Hard to get to. You got people duplicating efforts and things like that. So it's a good thing to know is what's your current state of your data is, and where you need to be. What rules are mandatory, what's optional, what's acceptable, so you don't spend endless times trying to figure these things out before you start into a project. Because the projects that we do, or you start with, or you're trying to be more efficient with your data, it requires good information. Especially in this day and time, we're being asked to cut carbon emissions, do more with less. So we need to have a good foundation to work with. So that's the first thing we normally tell our customers when we start working with them. Even if I'm a CAN operator and I'm a project manager, I make sure that, okay, our quality control and the data that we have in our systems are reliable. So I'm going to start with the National Underground Asset Register. This is a very unique project because it maps the entire UK assets in terms of electricity, gas, water, your DOT utilities, your high-speed rails infrastructure is underground. So approximately 4 million holes are dug in excavations dug across the UK every year. The data relating to underground assets is held in multiple different locations. There's like somewhere up around just shy of maybe say 700 asset owners, different companies that own that data. The information is fragmented. Significantly, the quality and format varies. And every time that they go out and they dig up a hole, that it carries a risk in terms of causing damage and injuries. There's about approximately 60 strikes a year. When I say strike, that means that somebody's cut into electrical cable. God forbid they hit a gas pipe, they cause a water leak. So, and that's all because of the information that they're looking at may not be as accurate as it possibly could be. The estimate cost for the utilities in the UK is just short of 2.5 billion per year. How it affects the UK economy. Now, if you think about it, you got these 650 different owners. The type of things that we were looking at was, okay, who owns the data? They already had each utility company already had, say, for instance, they had a what they call a call before you dig company that would take their information and dish it out to all the other utilities or builders who may need that information. But the problem was that each company had different service providers that was putting data out there for a call before you dig, and a lot of times you couldn't see everything together. So it was really taking time and effort and not getting what you want, which is why they decided to let's put everything on one platform instead of having all these little different systems showing where my cables, my pipes, my railway network data cables are. So they wanted to put it to where people can get it, because the asset owners, like a utility company, for instance, or a gas company, they are obligated to share their data with others in terms of if someone needs to dig in the area, if a resident just wants to know where his connection is, they have to be able to share the information. So that's the why of it. So what we decided to do was we decided to give them a platform where all the utility companies could upload the information into a cloud. We gave them a particular application where they could upload their data, and then we would bring that information in, and we would cleanse the data based on the agreeable formats that the asset owners agreed to. It's like you have a gas pipe, it has to have a different symbology, a different color. And then what information if you want to go with that, let's say water pipe or sewage pipe or telephone cable and things like that. So all those things have to be worked out. So the National Underground Asset Register is an interactive digital map of underground pipes and cables that we feel will revolutionize the way we share data and understand what lies beneath the ground in major cities. If you think about it, the UK is probably the size of Florida. So you know Texas is much larger than what Florida is, but the UK has got all these big cities like London and Birmingham and things like that there, where you got a lot of underground assets there. So Nunar is expected to deliver around 350 million per year in benefits. Asset owners will have less fines, they have an easier way of sharing information, and you get the bigger picture of what's going out there. So you think about it, you got 650 plus asset owners all having to work together to build this particular underground map. And it also will give them other benefits. So the next thing is they'll be able to streamline the way the data is shared between owners of underground assets and those who dig up the ground, taking away a lot of the administration of trying to get the data there and things like that. You present a big picture, like I said, a single format that's consistent color coding, symbolization, so there's no guessing. The problem they had in the past was that each utility had different ways of capturing information, different symbologies. So it was no consistent way of looking at information. So that was a risk to the people who had to go out and work with this data on the ground. So you provide a way, the platform provides a way for the owners, the asset owners, feedback in terms of, let's say, like, if you tell me your cable is, say, 5 feet from the curb on this particular street, and I figure out that it's not, it's more like 7 feet from the curb, then I can correct that within the platform, and it gives them a feedback. So while doing these kind of things, it helps strengthen the platform and also the underground structure. So all 650 plus asset owners will get feedback in terms of where their assets are. Now, the workflow that we went through in terms of how we put this thing together, because we had to do a POC, a proof of concept first. Doing that proof of concept, we had to understand from the asset owners, getting them all together and say, okay, what should it look like? What does a pipe look like? What does a electric cable look like in terms of symbology and color codes? What other information should we have in here that's going to be valuable to the users who are going to be using this information? So we had to do the schema mapping, making sure that we had the data and information that they wanted to capture in the field. If there's abandoned pipe there, is it as-built pipe there, so material types and things like that. So all those kind of things were worked out, tightly coupled through project management, also with technical people who knew their data, because a lot of the asset owners still had the people who actually drew the maps up, or either someone who worked with them in the past before. So, okay, how would the mappings be shared? We had to determine that and how to configure that. What needed to be validated, and then what data ingest specifications that we needed to do. So we had to get the owners to agree to that in terms of what it should look like, how frequently the data should come in there, what's the feedback that's going to come back to them and things like that. And then we had to put together a consistent way of resupplying the data once it came back. So what we did was we had what we call a change control document. That's every time that we take data from an asset owner, we are able to log in what was provided, what changes we had to do to the data, and then if there's any data feedback. The data feedback will come from the field when somebody goes out there and see that the information is not where it's supposed to be in terms of being accurate on a particular map. And then we get the owner to understand those things and get that feedback to them. So what we came up with a workflow is in terms of the asset owner is able to log in, he's able to supply his data, put it in, let's say, in a particular area on their service. Data gets picked up, but it also gets validated at the same time. And the owner didn't have to worry about what type of format that he had. Let's say you got 650 different platform owners. We just told them, give us the data in the format that you have and let us worry about the rest. So we were able to understand that, and then with all the different formats they came in, some of them gave you TIFF files, some of them gave you GML files, some of them gave you AutoCAD files. It didn't matter to us. We were able to digest that information. So with the schema mapping that we did, that will correlate whether it's gas cables, say water or sewer, or electric pipes and things like that. We were able to automate that. And then when it comes in, the software would check it, and then we would transform it, and then we would upload it onto the platform. Now, when you get the data onto the platform, you can only see your particular area, but I'll kind of like show you a little short video of that and how that works. So we had to have a simple, secure future supply and resupply. The API that the owners have access to, this is a workflow. It comes up into the system. It gets validated there. The first time through, schema mapping, we transform and digest it. We save any new mappings that come through. Then we update the data ingest specification on this one, and it gets published. So when we come back to a resupply, because data is not stagnant, it changes because of all the construction work that goes on, new housing developments, let's say natural disasters or something like that may happen, something would change your network. That data it comes in this way as a data resupply from the owner. So first you establish the information, then keep that updated. So we have an automated way of checking the information to make sure that it's correct. And then you always have what you call these mapping exceptions, something that doesn't necessarily meet the norm, but we record that and the software picks up on that and say, okay, we had that before, now we let that go through. Then again, here where we apply the map savings, and then we transform it into the platform, and then we update any changes of data ingest specifications that were agreed by all the asset owners, and then we publish it onto Numa. So it continues into a loop to where it's that, okay, now every time that we need to make this update, we're able to do it in an automated way instead of having a lot of people have to go through and check that information to see whether it's right once we've established it. Now, who uses this information? Who uses this data? Well, you have the data users are city planners, any excavators, utilities, MTA, builders, elect, data suppliers are utilities, municipalities, transit authorities, and city governments and others. Now, what NUNAR opens up for the UK is that, okay, you can do other things now. Now you're getting to see the big picture. All the utilities and telecom companies and transportation DOT companies are working together to build this particular map where you can see what's under the ground. That is a revolutionary thing that's happened there in the UK. And the benefits will continue to grow. Now, what else can you do with this information? So now they can start looking at, we have an established base of what's underground. This project's still going on, but they're making headway trying to finish. But now you got another way, other things you can do. Now you can start looking at, okay, digital twins, or we can start excavating together. You can plan with other utility companies to dig once and then lay your cables or pipes or whatever infrastructure you need to put into the ground. And you have a more accurate map base. So you can plan things a lot better by collaborating with each other, knowing that the data quality is stable, and you keep enhancing that data so you can do a lot more planning. It saves you a lot more money in terms of going out into the field and doing work. So from a GIS analyst standpoint, I can do a lot more modeling now. Let's say I can start thinking about pulling information from my ERP and looking at, okay, where should I start my maintenance work now based on ages of pipes and things like that. You can start to do a lot more with it. Now you have a platform established for future things that's within the GIS realm, the things that we can control. So you also stop going out to the field so many times, so that cuts down on carbon emissions and things like that. So it's a lot of benefits that they've gotten from this, and having a one platform where you can see the big picture of what's underground. And it's easier to get information from this system. In the past, the companies I was working with, what they would do, utility companies, especially water companies, if someone asked them for maps of their data, they would send that request offshore. It would take about, say, maybe a day or so for them to get the information back. to give it to the persons who asked for it. They had like maybe say 20, 22 people offshore putting this stuff together and maintaining that information. So and they were not getting the feedback. Maybe they got feedback sometimes, but there was not a vehicle for that. So with this particular application, it saves them a lot of time and effort because you've automated the process in terms of data quality and also being able to share the data. So I don't want this to go, don't want that to go there. Let me go back to here. Go back. Okay, so this is the key. These are the key benefits they got. So let me go back. Previous. Sorry about that. Like I said, the asset owners didn't have to do anything. They just gave the data in their own format. So there was no cost to them. Asset owners engaged in the process. Let's say like you had some water companies that never probably talked to each other, but now they're able to talk to each other and then they understand each other's data. So it's easier for them to work together and also getting feedback from others that say that, okay, these are the errors that we found, and then they go and they fix those. Then the burden of reloading the data back into the platform is simple. We give them an API to do that, and the software takes over from that particular point. Then you got documented transformations. Anything that changed in the data, you understand when it was changed and what it was changed for, who and changed by whom. And like I said, it promotes coordination between organizations when they're planning excavations. Now these guys, they can plan together and say like, okay, we're gonna dig in October on this stretch of road, then all utilities involved, whether it be cable, it'd be water, gas, or electricity, they can all work together, dig once, and then they're done. Go back here. So I want to show you just a clip of what it looks like. Give you an idea of what it looks like. Let me go back. Just a second. Okay, here we go. Street works, not that one. Just a second. Sorry about that. Not this one. Okay, I'll skip that because I can't get it to get Jack right. Just a second. Let me just skip that. Let me go back. Okay. Let me just skip ahead here. I couldn't get that to work that time. Let me just skip ahead. Okay, so I'll skip the demo. I'll show it at the end.
Hey,
There's
Kenneth,
yes.
Kenneth, I'm sorry. You are in presenter mode. Can you swap it around?
Okay, just a second. Let me go. Can you see it? It's
Yep,
okay now?
perfect.
Okay. All right, so the next project I'm going to talk about is the Northern Gas networks. What we did with Northern Gas, their problem was they had to do traffic management plans. And traffic management plans, when they go out and dig up a piece of road, they have to set the cones a certain way. They also have to notify their customers that's going to be affected with the dig. And also they have a thing in the UK what's called vulnerable customers. So they have to cater for all that. And the problem with the regulations in the UK is in like a huge manual. They have to interpret that and put that work by the manual and say, okay, this is how we go out and lay out the street works into the roads. So that was taking them some days to do that. They normally, it's a manual process. We normally send it offshore to another third party to do. It takes some days to do that particular work, and I'll just show you what the manual looks like. The previous one. Let's put up a manual real quick. Nothing's working on my PC today, so I'll skip that. Let's see. All right, so the first step of this is that you select a big area on the map, and then you let the solution create a compliant plan within a few minutes by configuring the industry standard rules. The industry standard rules is like it's probably about let's say that's 200, 300, 400 pages document that's in there that tells you how to lay out a road based on whether it's near a bridge, a school, a housing development project, and it can be subjective sometimes. So sometimes they go out and they lay out the roads, the traffic signals, the cones and things like that. And then the regulator comes along and say, well, you know what, that's wrong. It's not in the right way. So instead of having a subjective type of specification, we took the documentation that the regulators gave us and we put that into a particular software. So now what the operators have to do is the engineers have to do is just go to a CAD solution and select a particular area where they're going to dig and say, okay, I'm going to dig over here, for instance, and then the software does the rest. It looks at the specification based on where the road is and say that, okay, this curve is here. It's near these housing developments. Then these are the rules that we apply to that. So the software goes in, automatically produce the plan within about 60 seconds, rather than taking days to do that particular work based on the specification. So it's going to consistently give you the information that you need in terms of complying with the regulations and not being able to have to worry about the regulator coming out to the field and say that, well, you know, you got the cones in the wrong location, because they get fines for that. The longer they have to stay out into the field, and plus they don't bring the right equipment out there, they get fined for that as well. So as I was mentioning that in this step here, you highlight the particular area that you need, and then the software pulls the data up. It tells you from the street center lines which customers are affected, but we also had given them a particular application that on top of this app that would say these houses have vulnerable people in them. So these people are the ones that you need to cater to first, let them know what's going on, how long they're going to be out. So then the software just calculates all of that information, produces a plan report that when the regulator comes out, they can hand that to him and say, okay, this is what it is. So far that when this comes out, we don't have any kickbacks and things like that in terms of saying that you don't meet the regulations for the gas company. So everything it works out fine. Plus, they're able to cater to their vulnerable customers, and the app also pushes them. We call it incident management. It also tells them what to do, because when you have a vulnerable customer, you have to know what type of vulnerability they may have. So they need to know how long the system's going to be out. Do they need, say, water, or do they need to move to another location and things like that? Because some of these people are on kidney dialysis and they need to have heat or water and things like that. So This helps not only just the gas utility companies with the excavations, it also helps the electric companies, telecom companies, everybody in terms of who has to go and dig up the road. So again, we did the same process we talked about before, getting the specifications clear, understand what they are. We automated those, put those into the GIS, enable the GIS to make that decision for you based on what's in the rules and regulations and specifications. So the key benefits from this, it reduces production time and costs of traffic management plans. As an automated system does not require multiple amendments. There's no going back and forth. There's no arguing between, no subjectiveness. It's as per what's written in the specifications. Reduction of carbon emissions, fewer site visits, automated and consistent compliance with industry regulations. So we're talking about having a sustainable way of managing your assets, doing an automated process, the way we did this with Northern Gas. It gave them that. It avoided delays, it ensures safety, and reduces the fines and things like that, which the companies with Northern Gas benefited from that. They were no longer getting any fines anymore. It allows utilities to work with local authorities in a way that minimizes disruption. Because you ever driven down a road and you see all this, you got your roads blocked off because you can't go home. Well, it's because they have to have certain ways of blocking the road off so people can keep safe in terms when they're digging up the roads and working with the assets. It enabled rapid and accurate, efficient decision making. Like I said, using clear, ambiguous format accessibility to all stakeholders. So even if the CEO can see what's going on, there's a report that's generated. It tells, okay, did we get out? Did we cater to our vulnerable customers? Yes, that was able to do that. So it's a way for them to move their business and not be held back because of someone didn't understand how what the regulations said. And the regulations, when you read something, it can be subjective. So we got around that with the GIS and gave them a tool that automatically looks at the data, looks at the specification, and builds the map where people can see, and also gives them a compliant report. Now, this comes from the head of innovation. He said that the ability for our designers, planners, and engineers to generate traffic management plans at the click of a button is a potential game changer for the industry. Working together with Northern Gas, combined their technical experts, that was us doing that with One Spatial to produce this award-winning and innovative system. So it definitely saved him a lot of time and effort and money. And it made it much easier for them to do their particular work in terms of they had to go out to the field to dig up the roads. Now there are multiple companies that are now using this application. So go back to what I talked about data. The first thing, before we were able to service these two projects, we had to get the foundation right. The projects, clearly the London, the National Underground Register needed an automated way to validate the data. You couldn't have people that was just trying to check that, or you couldn't just throw it offshore for people to do that. These things move fast. I mean, data changes at the speed of light. So we had to have a way to get that information and into the system, because there's regulations that once you do some kind of construction work in the field, it has a number of days to get added to the overall system. So the automated data validation removed the manual process, and also it gave them a certified proof of the data quality. The automated way tells you, okay, your data quality is based on what you set it to be is 95%, 98%, 100%. So you can't get around that particular thing. Now, when I talk about those 650 asset owners working together. And if you can imagine that now they all have a way of accessing the data. Data's been integrated to build that national map of the UK with all underground assets and all the utility owners, DOTs are sharing information. They get the big picture of the data. If I go and I talk about Northern Gas Networks, before we started these innovative projects with them, they came to us and they said, well, you know, we have our data stuck in silos. We don't know how good the data is. So could you help us? So we went in, we were able to integrate their data. They had data in the ERP system, they had it in GIS, and they were doing double entries in those particular areas. We cleaned all that up by, first of all, giving them an assessment of what the data looked like, and then integrating those systems together based on their rules, what they had in terms of what they wanted to see and which one should be the true source of information. So we fixed that part for them, allowing us to be able to enable them to use that traffic management system and other things like we talk about the incident. So data enhancement, that was the first thing that we kind of look at in terms of how to keep the data clean. As data gets added into the system, there's automatic cleaning tasks. You can create new data, you can construct repeatable checks, non-subjective corrections and actions. Software does all that. Sometimes you may have to go in and do some manual tasks, but these organizations, this is what they're using in terms of being able to automate the way that they do their day-to-day business. So the business problem we identified and said, okay, if we did this manually, it would take us a lot more time to do that work. But now by automating it and also making sure our data is clean, even when we add information to it, because like I said, data is not static, it keeps changing. We keep adding to it. And with the one, when I talked about the Nunar project, the feedback that comes back to the asset owners, allow them to enhance that information, and then the software goes back and check to make sure it falls in line with everything else. What we did for the Nunar project, do the same thing for NGN and any other utility in terms of making sure that when you put data into your system, once you clean it, you cleanse the data, you have a way of repeating that action over and over again. So you don't waste all your money cleaning up the system and not being able to use the data. So make your data work for you. This is another project that I worked on, I've been involved with. It was more or less the water companies in the UK, let's say Thames Water, for instance, is one company that's there. Leakage is a big problem all over the UK. I mean, you have an aging infrastructure, and based on a set of rules that we looked at, the age of the pipe, its location, how long it's been there, what's been heavy use of heavy roads and things like that, and looking at some other factors that the water companies gave us, we were able to come up with a way of saying that, okay, these particular pipes over in this area, they most likely don't leak. They're going to have a leak based on the age of the pipe or based on the location and the other factors they were giving us. We did some field checks in the field with that, and we discovered that it was about 90% correct in terms of seeing what a leakage is going to be. So this is an ongoing thing. We're still trying to redefine that particular thing, but that's what you can do when you have good data and you have a way of accessing information using automation to read the information that you already got in your system and using it and getting value out of that information. Now, a couple of industry sectors that we're able to use the same type of workflow. When you go in, understand what the information is supposed to be, where are all the data owners, what are the rules, and what are you looking for? So once you are able to identify where the information is coming from, the data owners, we're able to automate the process in terms of making sure that when your PSAPs and things like that come in, that data is cleansed, it's ready to go to use in an emergency system. When I talk about pipe inference, in the UK, they were able to, they had a problem. One particular water company had an issue in terms of understanding where their pipes were, because they had to take over a network that was normally used by private, that was normally responsibility of the resident owner of the particular property. So based on some aerial photographs we used along with some machine learning that we utilized, we were able to determine where the pipes were in the owner's properties. What we did was we also did a field check with that to see how accurate we could be in terms of inferring what a pipe is supposed to be, where it connects to a particular manhole. The reason that was important was that we talked to a lot of the construction crew, and they were getting fines because when they had to go out and, let's say someone calls them up and say, well, you know, my sewage or my toilet is blocked, it won't flush, it's overflowing. So they have to come in and determine which manhole and which pipe that they're connected to, and then try to blow it out. Well, they were getting fines because they was hitting the wrong manholes and blowing up the wrong houses, people's bathrooms, and they were getting fines and had to try to find a way to be more accurate. So that's what this pipe inference come in. So we did some field checks with that, and that's something that's undergoing. Incident management, I had mentioned about that in terms of the NGN project work we did, where they had to work with, understand where the vulnerable customers are, which customers were being affected, if that was a blockage, if that was say like a gas leak, something like that. But the incident management app, based on the information that you got in your database, would tell you need to go address 1, 2, 3, and 4 first, because those people are, let's say they're in wheelchairs, they have mobility issues, they may be on kidney dialysis and be moved. So the incident management map just tells them, give them a guide to where they need to go. So these are some of the things that you can do with automation and making your data work for you and be more efficient. You can imagine, if you've been like me and you work with a lot of checking of information and databases and doing it manually, you're still gonna miss something. But with an automated system that's based on the same specifications, you are able to get to the information quicker, get your data cleaner, and also spend less time and effort in terms of redoing stuff. I know we just put science up on the board when I was doing CAD as a project manager and CAD manager, do it right the first time. It's tedious work. People are gonna make mistakes. But with an automated system, once you clean your data up, that system still monitors what goes into your database, whether it's in the field, you catch it on a mobile, or you catch it on the desktop, it can manage that particular thing. So like I said, data management, the cleansing of the information, it doesn't matter whether it's non-spatial. Data integration is a way of getting things to work together. I talked about machine learning and things like that, how that can help you. Knowledge and insight. We take the knowledge from the asset owners and use that within the configuration of the software, whether that be the underground Lunar project, how we taking the knowledge from asset owners to identify their cables, their pipes, and things like that, and these characteristics about it. We use that, and then making that knowledge actionable, driving the value of your data. Instead of having someone who's been there for years, and then you're going to retire, you kind of put that knowledge into your own system. Now, whenever we started on these particular projects or any project, we normally do a proof of concept. The proof of concept is the business problem. What's the issue? What we're trying to solve, and then we come up with a way of solving that particular problem. Then we go to the prototype. We actually build something and say that, okay, from the prototype, this is what we want to do. With the National Underground, what we did was we took the Olympic Village, and we took all the cables and pipes within the Olympic Village in London, and we built a prototype. From that prototype, we realized what we could do in terms of capturing that information and allowing people to share data across, for underground data across the UK. We did a pilot. We took the bigger portion of information. We took the City of London, then we went to the north, say Nottingham someplace, and did the work up there. So once we got to the pilot part of it, we knew pretty much what we had to do. We did some refining of the software, and then we put that in production. So that's the normal way these things work. And understanding how long it's going to take, it comes out of these particular steps. And that's it for me. If there's any questions, I'll be happy to answer.
All right, thank you, Kenneth. We actually do have a few questions here. We have about 9 minutes left, so I'll jump right into it. The first question from earlier, Jeff asked, so NUAR is responsible for 650 plus different conversion specifications.
It's not different specifications. What happened was that the owners agreed on I talked about the ingest. They agreed on what the symbiote is supposed to look like. Let's say line, what information that they're going to share with each other.
Ken?
Yes.
Hi, this is Sheila. Do you mind if I jump in here a little bit?
Yeah, sure. Go ahead, Sheila.
I'm real familiar with this one.
Yeah.
So, and basically within the rules engine, you have the ability to, first off, the system can look at the schema that they determined that they wanted the national base to be set at. And once that's set, and they used an OGC standard called MUDI, and then once that was set, then they can use the rules engine to automate mapping of one schema to the other. So all those different data providers, they just map it one time. If there isn't a match, if the system has a point and click method to point to the appropriate matching items or fields, and then save that, and that's it. From there on in, all they have to do is submit the data in, and it automatically maps it and integrates it.
Okay, thank you, Sheila and Kenneth. So this is sort of a two-part question here from Melissa. So for the Northern Gas Networks project, what was the % error for how accurately the automated system applied the complex series of regulations? And second part, how was the system's accuracy tested or verified?
You want me to take that one too, Ken?
Yeah, go ahead, Sheila.
Okay, great. Yeah, so what they did was they went, they used business rules. And I mean, it's things like the type of property, any regulations around construction at that time for utilities, and the year built, all that kind of information, a number of different pieces of information, and configured business rules based on that to generate the inference. And what they did to validate it was they went out and did various spot checks in a lot of different places. And for the greatest majority of the inferred data, they came, I'm trying to remember if it was 3 or 5 meters, but they came within a very accurate or close enough to accurate. And then they could actually, as they went out and did work on these properties, then even align them even more.
Okay, all right, super. So we have kind of the same question from 2 different people. So Chase and Arcana want to know, in detecting leaks in pipes with machine learning, could you explain how machine learning is applied in that scenario? Is it detecting geometry or attributes or both? So basically, what are you using as a,
all of the above.
All
Yeah,
of them.
so
Okay.
one of the interesting things is the ability to go in and go cross database and do and bring in lots of different information to be able to then look at it. And I don't know that I necessarily really call it machine learning, because it's business rules. It's what do we know about the data or about the actual real world construction at that time, of the time it was built. And, you know, and that gives you the ability to, if you have that information, it gives you the ability to configure the rules and then infer information.
Okay. Okay. So Jordan is sort of kind of trying to build on that. So he says, so for instance, this kind of material has X number of records of breaking or something along those lines. Is that what you're getting at?
Where it breaks the rules, is that what you're talking about? I'm not sure I fully understand the question.
Jordan, do you want to elaborate? So he said,
Yeah. So like where the material is likely to break, or you have like asset management records of we
Right.
know that we had to go out to this line X number of times, or we know that when something in this area breaks, the resultant area has like a higher probability of breaking again. Are those the kind of business rules you're talking about?
They could be. It's very, what I like to say, data agnostic. So it works with spatial data and non-spatial data and can integrate, like I said before, the two different types of data. And yes, whatever is the type of information you're trying to determine, or you're trying to determine where your data may not be meeting business requirements, then those are the rules that get configured. What we like to say is if you can put it into a statement, then you can configure it as a business rule. You can't determine if something's pretty unless you can truly define pretty.
okay, all right, cool. So we have a question here, and I'm not entirely sure that you guys would be able to answer this, but we'll go for it anyway. So Nancy says, I work in animal conservation for a nonprofit and hope to apply a similar workflow and bring assets to GIS with about 12 organizations. Do you know where I can find funding to support a project like this?
You know what I would suggest is maybe you reach out to us and we can give you some possible ideas.
Okay, great. Thank you. Thank you. So I have a question actually. What is the platform that this type of system is built on? Are we talking like an Esri, or is this a completely custom deal?
It's not custom. It's actually, I mean, it's a actual product, right? And it's a
Okay.
standalone product. So it works with, like I said, data agnostic. Sure, it definitely works with all kinds of Esri data formats. It also works with computer-aided drafting formats. It works with completely non-spatial, like somebody mentioned, asset management systems, which often are spatial, but often are not. And, you know, so we pretty much work across the gamut of all types of industries. We even work for Google, who uses it to do all their real estate worldwide management of their properties. And they have numerous CAD files that were wrought with error. And so they have been using it to find where there's issues with that data and then get them fixed. And it can do automated cleanups as well. And then we're also working with validation between that and their asset management system.
Okay. And then in terms of time, so Kenneth had a slide there that showed, you know, proof of concept on the order of, I guess, months, and then all the way out to a final deliverable would be years. So, in like, let's say to do this for the entire, you know, country of England or UK, what's the timeline? Like, are we talking years?
Well, what's amazing about it is that this is, and so I have spent 23 years of my life working at Esri, so I'm fairly dyed in the wool of GIS and spatial data and familiar with it. It takes a while for things to actually get processed. But this, the way the system is architectured, it uses some very unique indexing and is able to really go quickly through the validations once they're implemented. So we have, I'll give you an example. We have a next generation 911 validation data supply chain portal that we stand up for a number of states. I think at this point we have like 7 states in LA County, who's like the 6th largest state. So, but and we are able to stand that up generally within a 4 to no more than 6 month period of time, with rules and everything, and having it where the people can be validating their data, all the emergency managers, suppliers of data for the state can be validating their data against NENA rules.
Okay. All right. Cool. Thank you. All right, guys. Well, that is our time for today. It is 1 o'clock Central on the dot. So with that, we'll go ahead and convene this webinar. Thank you again very much, Kenneth and Sheila. Thank you for your answers here at the end. So that'll be it for today. Appreciate you all attending.
All right, thanks a lot. Take care.
Thanks.